He is delayed, yes. We should. Yeah, so I'm not trying to look at. Do you know what to start? I just logged in. Do you know what I should do
Do what?
to connect to this? I'm connected now.
To connect to what? Oh, to run the slides?
Yeah.
Well, I don't know.
Yeah.
Oh, you plug your laptop into the Ethernet drop.
I don't need to. I mean, I have it on Wi-Fi, right?
Oh, okay.
Materials. The slide's not available. What?
Refreshing is without logging.
Just refresh the window.
I mean, that's what you had. I mean, it's,
Yeah. That's why I want to know the answer.
I think so because it's probably. Yeah, I also wonder if it actually is not refreshed on that list. If we can refresh the section.
Yeah.
Just start. And I don't like how to get the audio. People can listen us.
You get audio.
Yeah, the audio is wired in. All you need to do is share that to share from your computers to the slides. While we are getting ourselves a remedial share training here, do we have a volunteer to be a scribe and a note taker?
Yeah, right.
Which one? All right, can you be the note taker, please, Gory? Thank you. Reese, thank you. I don't anticipate this. For what? If somebody is on Jabber and can't use the meet echo, then you can relay to the mic. Or if there's like some huge blow up on Jabber, we would like to know.
Hey, if I were you, I would say that at the mic. I already did that once yesterday.
Are you?
I'm gonna share something.
I think you use the it's that thing there, right? There you go. If they're preloaded slides, why they're not, that can't be right.
Yeah, that's what I need.
It's in the agenda though.
Yeah.
All right. Well, yeah, you do need to download it.
I'm not downloaded it, but then how do I do this?
Dismiss that and try.
Share screen.
You can share your screen and do the downloaded thing. All right, I'm just going to start talking.
Yeah.
Welcome to TSV area, everybody. I'm sorry that we don't know how to work anything. Nevertheless, if you have not somehow seen the note well yet, please take a look at the note well. Most of us are familiar with it. Basically, if if IPR is a thing and if you have any IPR relevant to what happens today, you must disclose it. I invite you to type note well into your favorite search engine if you like and investigate that a little bit further. Today we are going to go through our usual AD slides about the state of the area in a moment here, and then we have a couple of invited talks on the theme of SCTP, and I'll say a few words about that later. We have slides. Look at that. Thank you, Zahed. I'm Martin Duke, and this is Zahed Sarkar. Next slide. We've already talked about that. And of course, we'll have open mic at the end of the session. Okay, just as a brief summary of the existing working groups, not a whole bunch of big developments in terms of big new work going on, I would say, in the working groups. We do have some chair changes. I'd like to thank Jan Seedorf and Michael Scharf, who chaired Alto and TCPM respectively. And a big welcome to Mohammed Bukader. And actually, it's not on the slide, but Ian Sweat, who are taking over Alto and TCPM respectively. Do you have anything to add?
So you can hear me, right, Rick? So yeah, for the working groups I'm responsible for, I think the DTN rechartering has been done, new work coming in. There is a session today after in the afternoon, and there we are having some sort of like overview discussion on Vince will be talking, so you might be interested in going in. Um, Mm, Then we have Quick, always championing the deliverables and new items. I think one of the things that we could mention here, like they are started working on MP Quick extension, and there are a couple of drops they went for the RFC editor view, and obviously there are some new IDs on load balancing and version negotiation that if you are present in today's session, you know about it. RMCAT has one working group document that's in working last call. I think this is waiting for the work Schaefer's write-up. Anna is working on it. And then for the tabs, most of the things going as usual. Uh, we are just talking about new milestones, about some mapping over quick. So that would be all, I think, from my side.
Yeah, the only thing I would like to highlight is in TCPM, RFC 5681 is most of you know is the sort of core loss recovery document, the sort of semi-modern version of that, and we're looking to BIS that, but no one's really stepped up to do that. So this has come up a couple of times, but no one's done the work. If you're eager to leave your imprint on a fairly foundational document for TCP, that is an opportunity that is available to you. Next slide, please.
So, hi, Lars Eggert, former technical TSV person. So I could be convinced to be an editor for it, but I need people who actually know this stuff to be authors. But I'm happy to run the GitHub and stuff and merge things and push it up and so on, like I do for Cubic Disk.
Thank you, Lars. So you could just contact Lars or me or the TCPM chairs if this is something that is interesting to you. Thank you. Doc is pretty busy. Not quarter, but 4 months. Document-wise, a bunch of stuff went to the RFC ed. 4960 BIS, of course, is the new rev of SCTP. IOM data was a pretty big effort out of IPPM to get some in-band telemetry. The whole slew of Alto's last charter made it through to the RFC editor. So that's 4 documents. And Quick Datagram is another big one. On the RFC side, things coming out of the queue, the whole DTN last charter set, a bunch of IPPM stuff that's kind of a grab bag. And while it was not out of the TSV area, technically, I wanted to call your attention to 9187, which is Joe Touch's document about sequence number extension, which obviously has a transport flavor. Anything to add about this, Sahid? Okay. TSV art, as usual, we like to call attention to what's happening with the TSV art. Thank you to all of our reviewers. You can see there in parentheses the number of reviews they've done in this last cycle. And I think the takeaway there is there's not an enormous volume of documents to read. So I really invite you, if you would like to get a bigger picture of what's going on in the IETF and how it relates to what's happening in transport, I invite you to contact Magnus about adding yourself to the rotation and helping us out as ADs a lot by providing another set of eyes of other things that are coming out of IETF last call.
Just to add to that one, I mean, I think we understand like sometimes we cannot make the review even if you are in this team. So it would be great actually to you inform Magnus or the other secretaries or us that you are unavailable for a particular time period. That will help us actually to scheduling it better. So yeah, thanks for the work here.
Next slide. There's no next slide. Oh, right. Okay, so let's call up the other presentation. So we have, as I mentioned a couple minutes ago, we have two presentations on the subject of SCTP. Obviously, we shipped Quick quite recently, and that has a number of SCTP features. So some of you might be wondering, what's up with SCTP? Is it still relevant? We have a couple of speakers today that will argue that it is. I think we'll start with Michael Cookson, who's remote. And Michael, are you there? He's there. We need to give him.
Yeah, I am there.
Ah, there he is.
You can share your screen.
Okay, and
You
we'll,
want to share it by yourself?
would you like to control the slides, or should we?
Do you see them? No.
Not yet.
Not yet.
I think
You are not sharing, but we can share if that's a problem for you.
But how can I use Medeco for doing that? I think they need to be uploaded and then I can select them, right? Sort of.
Why don't we just do it? This seems like it's a problem.
Okay.
You can do that.
Okay, Michael, take it away.
Yep. Okay, next slide. So I don't want to discuss too many technical details of SCTP. I just want to highlight the services SCTP provides, and I'm focusing more on why things are provided and why are things have been things integrated into SCTP. And that gives you, I think, should give you a better understanding when you can use SCTP or another transport like maybe MPTCP or Quick or whatever. So things started, I think, more than 20 years ago, and the original use case was to be able to use an IP-based network for transporting SS7 signaling messages over IP. That's telephone signaling, classical telephone signaling. And although I'm focusing here on that, the use cases where SCTP is used up to now is sometimes still that, and sometimes other signaling which has similar requirements. So the SS7 stuff, what was special about that, it was what you transport, or what you deal with is small messages. Small meaning 100 bytes is not a small message there. And you need to transport them reliable, but the ordering requirements are not that you need complete ordering, but only some messages need to be in sequence. So from a telephone call perspective, all messages belonging to a single telephone call need to be in sequence, but you can interleave messages from different telephone calls without any problems. So only partial ordering is required. You have pretty strict time limits for delivering the messages. So this means the time between the sender sends it and the receiver processes it. So it's not about queuing delay or retransmission. So it's an end-to-end limit. And this means you need to minimize head-of-line blocking. So if you are delaying the processing of a message without any good reason, that's not a good thing. And the last issue is that you need a very long lifetime of the communication relation. And you need a high level of reliability. So long lifetime means an SCTP communication relation can be up for a year or something like that. And to avoid this, you need to avoid single points of failure. So normally you have multiple network connections and you need to fail over in a very fast time limit. Next slide. So that basically motivates the base protocol features. You have reliable transport of user messages. So it's message oriented. You can bundle multiple messages in a single packet because you want to do that efficient and messages are small. You can have multiple streams and only messages sent on a single stream are delivered in order. You have also support for unordered messages. They are reliable, but you deliver them as soon as they get to the destination. Dealing with network failures is handled by using multi-homing. So you have multiple IP addresses on each side, and you supervise the paths. You want to know which paths are working, which ones are not working, that in case of you need to fail over, you fail over to a path which is working. And the use case, so the protocol was developed in the IETF, so all the dimensioning, the timers, and that stuff is selected for the big I internet, but this is not the parameters which are used when you run this protocol. So they are much stricter timers and this stuff. So you need to be able to configure that on a very fine-grained way. And there is support for large user messages, so you can transport them, but that was not the focus of the protocol. So that's why you get some head-of-line blocking if you actually do this. Next slide. So over time, some of the limitations of the protocol were worked around or addressed. Several things were done pretty simple when the protocol was designed, because it should be on the market very fast. So I think it was about a year between the first version of the protocol and it went to the RFC editor. So the features are basically, you can dynamically reconfigure the addresses. Normally the addresses, in the base protocol, the addresses are negotiated during connection setup, but you can change them over time. This was hard to get through the IETF, but it's done. You can increase the number of streams and reset them. This is basically, if you don't want to tear down the communication relation to just increase something or change the addresses. We have partial reliability, so that addresses a point where the application, for example, runs a timer, and when the timer runs off, for example, it supervises the call setup. And if the application decides, no, it didn't work, then it doesn't make sense at the lower layer to still retransmit the messages. So that's why partial reliability went in. The base specification has an abstract API, and there is also, it was also worked on a concrete API just to make sure that you are able to configure the parameters you need to be able to, that you can actually do that. That was very helpful, and sometimes still an issue that you can't tweak some of the numbers. There were documents to improve the failover, and additional lower layers were added, so you can run, the base spec only runs over IPv4 and v6, but you can run it over IPsec. Originally, SCTP was developed like quick over UDP, but it was changed to run natively over IP, and a later spec brought back the Udp encapsulation, and you can run it over Dtls if you want to even encrypt the transport information. This is used in Webrtc, which is a use case which came in later, and large user messages are also an issue there. So the handling of large user messages was improved to avoid head-of-line blocking, and several stream schedulers were specified, which is a local issue on the sender side, but you might want to have a defined behavior when you run certain applications. And the most common way to secure SCTP traffic is with transport layer security. So there are specifications for TLS and DTLS over SCTP. Next slide. Yeah, that's the Webrtc use case. So basically, SCTP is used to multiplex data channels and provide a congestion control for them. So you can have multiple data channels in Webrtc, which are a symmetric channel. So the properties in one direction are the properties in the other. And SCTP allows you to basically to open and close these, to run them ordered and unordered, and reliable or unreliable, where unreliable means the number of retransmissions can be limited or the lifetime of user messages can be limited. This can be combined in different ways. So you can have unordered but reliable, or ordered but still unreliable in some sense. And this is sort of hidden from the user who doesn't see SCTP. He just sees or selects these ordered, unordered, reliable properties, and that's it. Next slide. Yeah, so the question is, so this is how SCTP evolved in the IETF, and as you see, it's mostly related to the original use case. There are some points which we didn't achieve in the IETF. I listed a couple of them. So the parameterization for signaling networks was something which was brought up a couple of times because it was important for people running SCTP-based communication, and they wanted some guidance on that. But the argument was always that's not the internet, so we don't do that. There was an interest in specification and specifying conformance tests, which also was not possible to do, but that's still something which is done in deployments where people test implementations before they take them into service. The SAC, the acknowledgement scheme in SCTP, is in a way that you can renege, and there was an extension to do it in a non-renegable way, but that also didn't went through. The multi-homing in SCTP is used for network resilience or fault resilience, and there was an idea to do it also for load sharing, but that was also not acceptable, and ECN support didn't make it. Next slide. So the current activities in at least TSV are still working on an old document about NAT. And it seems to be coming up in the context of Linux container stuff, which seems to use NATs. And if you want to run SCTP there, then it seems to be an issue. And the other one is an update for Dtls over SCTP. There is a specification which has its limits because it was written when only Dtls 1.2 was 1.0 was available, and 1.2 and 1.3 are different and don't provide the same services. So there is some work needed. Next slide. That's actually what might come up. One is the document for Udp Encapsulation has an issue which is written up in the document and in the draft there. And instead of having a separate document saying you need to do this also, the idea, I think, of the former Transport AD or so was to just do a BIS document to have one complete spec for that. So that might come up. The other one was the 4895 BIS SCTP auth. The algorithms there are only HMAC with SHA-1 and HMAC with SHA-256. And during the discussion for the Dtls BIS document, it came up to have also other algorithms there, maybe obsolete SHA-1 as a must to implement. So that might come up. I'm not aware of a lot of more issues. There's some textual cleanups, but nothing fundamental. These two things are maintenance, could come up. The other one, new features. One could do improvements for Webrtc. Simple ones like you don't actually need the checksum. I'm aware of some implementations not using the checksum at the SCTP level because it uses on some platforms a substantial amount of cycles. You could do a fast open style setup because you don't need the cookie protection, something like that. You could do association forwarding to allow any cast-like features, which I presented, I think, an IETF ago or so. If you want to do load balancing between multiple points, you can do that. Or I think Ericsson brought that up. You might want to consider a full mesh model. So in SCTP, the multi-homing is you don't consider the source address peers. You only supervise the destination address and not the destination source address pairs. That's what I wanted to say. Yeah, so that should give you an overview what the features of SCTP are. Some of them are available also in other protocols. Multi-streaming in QUIC, multi-homing in TCP, MP-TCP, or upcoming in MP-QUIC. But it should give you a feeling what the services are and why they are there. Any questions?
Any questions for Michael? We're going to have Claudio go talk a little bit more about, or dive a little deeper into the service provider use case, but does anyone have any questions for Michael?
Gori first. I wasn't going to ask a question. I was going to try and provide a tiny extra context. We looked at path failover with SCTP, and we did work there. We pushed back on multipath because at the time that wasn't a thing. Now it is. Maybe that is also something that we could potentially look at with SCTP. Just because I pushed back once doesn't mean that this is a bad idea. Similar with ECN. If ECN becomes popular with other things, then maybe it fits there. So maybe there are a few other things that I could see might appear as useful things for SCTP. And because we did them previously and said, don't do that, maybe we'll say, do that next time if they're proposed again.
Jana?
Hi. Thanks for the presentation, Michael. It was great to go over that history from 20 years ago a little bit. The question I have, and is in terms of its use cases today. How much do you have a sense for how much SCTP is being used right now for SS7? The other was the original use case, and I always thought that it was successful in that direction quite a bit.
So I'm aware of that it is still used in that use case. So it's still so machines are still being brought up in network operators networks today with that use case. There are other use cases now with diameter or something like that, and I think Claudio is giving in the next presentation an overview about how it is used in 5G or something. 5, 6G, something like that.
Still in signaling.
Still in signaling, and I guess the motivations are still the same things, like redundancy, so that hasn't changed. The protocol on top has changed, and maybe also the timers have changed.
Makes sense. Thank you.
Jake?
Sorry, I keep mixing up the video and screen share buttons. Okay, thank you, Michael. That was interesting. I had there's a lot I don't know about SCTP. I've never really used it, but the feature you mentioned about partial reliability and sending with a deadline, partial reliability with a deadline. This reminded me of one of the features I thought was really useful about SRT that I heard about, in the last couple of years at some point. And I know that that's had a lot of uptake in the video space. Do you have any insight into like why SCTP was not sort of the go-to for solving that problem? Is this a performance thing, or it's geared around the smaller messages and so it doesn't work as well for the larger messages, or like what's the it seems like it would have been way easier to just run one that's already written if that worked, right?
I don't know why. I have no idea.
Okay, I was just curious. All right, well, thank you. This was neat.
Okay, Lars, and I'm going to cut the queue unless someone enters immediately.
Yeah, Lars Eggert. Back when I was AD, right, we had basically SS7 was the use case, and there was also still some hope that SCTP would be like the general next generation transfer protocol, and that really hasn't sort of happened. But then WebRTC happened, and SCTP actually did see like a major new use case that nobody really had on the radar. I'm still sort of the problem we had back then was that we could never get adequate review for these SCTP extensions because the community was very, very small. Has that changed? I don't think so. And then I think we're going to be fundamentally in the same situation where we have basically nobody with an interest to review this thing or these things adequately. I think that's something it's not a technological issue with any of this, right? They're all probably reasonable, but we didn't really manage to review stuff back then. And I wonder if that's changed now.
So there was a group of people being interested in SCTP and doing reviews. It was not large, but there were a couple of people doing it from different companies, vendors, or whatever you would call them.
So that's a new application on top of SCTP. What I meant is like people who actually implement SCTP stacks, because as far as I know, there's exactly one implementation that everybody's using, right?
As far as I,
you have another one.
So as far as I,
says Ericsson has another one, so I was wrong.
Nokia has another one.
Okay.
So I'm aware of a lot of companies in the telco area having their own implementations. Some companies even have more than one. And with WebRTC, there are multiple other implementations focusing on that particular case. So I'm aware of Google. I'm aware of other implementations in other programming languages. So there are multiple implementations available.
So we need to move on, but Lars, you did raise an interesting point about quality review. There is a pretty good pipeline for proposed work in this area, and I'm always asking the question: can we farm this out of TSVWG to take something off their plate? And I did a bit of a poll, and I think 6 or 7 people said they would attend a working group that did this. Now, who knows what percentage of the actual attendees that is, but it was a little bit on the low side to separate it out. So whether TSVWG is, whether those additional people in TSVWG are actually reviewing the work, it's hard to say. But yeah, that's always the concern. All right, let's move on to Claudio's presentation, which dives a little deeper into service provider use cases.
Thank you. Can you hear me today?
Yeah, it's much better.
Hello?
Yeah, Claudio, I can hear you. Go ahead.
You can't hear me today, or?
We can.
Michael.
Or you can't hear us, perhaps.
Hello, can you hear me today? Oh, perfect. Because
yes.
don't hear you. Yes, okay. But let's, I try to do what I can here. So, well, somebody asked, where is SCTP still used? Just look around you. It is all around you. It's used everywhere in the world. Every day there are thousands of new deployment of SCTP because it is used in the radio access network. So it's not your mobile phone that is using SCTP, but the next hope, the radio station, is using SCTP. And there are some special reasons why it is used as SCTP, and possibly some of the reasons that were not really the real objective of the first design of the protocol, because we are not using SCTP with SS7 in the radio access network. SS7 is not there anymore. and we use it in a very peculiar way. So let please switch to the next slide, and I will talk a little bit about why it is there. In front of you, you have something like the current radio access network. So you have some core sites, you have some central sites that are cloud-based, and you have the radio site. Here, I show you that they are all connected with the lines, and those lines, they represent the SCDP association. It is the control plane. So it's not really the message for the end user, but it is the message that enables the end user to do what he wants to do with his mobile device. So for instance, if you want to get more bandwidth because you are watching some movies on your mobile phone, then it's your radio that will ask to the network, is this user equipment permitted to do more bandwidth? If so, then it will tell via control plane to the radio to allocate more bandwidth. So that is more or less the new way the control plane is controlling all the devices in the radio access network. And on the other hand, this is not internet, it is another network. It's often on VPN, so you don't have, you don't go into the public internet. It's often handled in a different way than we imagine a network. So quite often, each of these control signaling is encapsulated over IPsec for security. And also often this IPsec encapsulation is statically routed in order to keep under control all the possible faults between nodes or network problems. Some are single-homed, some are multi-homed. In the old world, when we were doing 3G, we had only single-homed association in the chain. But when LTE has been introduced with 4G and with 5G as well, we have started, or the customer, the operator, have started pretending to have multi-homing for redundancy, so that the network can be under control in a smooth way. Furthermore, when moving from 4G to 5G network has introduced a concept of migration. So when moving from 3G to 4G, there was no direct communication in the RAN between those generations, but between 4G and 5G, a new trend has been established so that we have a channel that connects to the generation, and this still is transported over SCTP. Somebody asked, is there only one implementation? No, there are more implementation, but thanks to the fact that there were not so many big changes in SDP, the interoperability between vendor is quite good, and for the RAN, for the net telecom vendor, interoperability is very important. And the lifetime of SCTP is in this way tied to the lifetime of the radio access network. So let's say that 4G will be still there for another 10 years, and then 5G has been just taken over now. So let's say that in 2035, SCTP will still be there. So if thinking about a replacement for SCTP is something that should be planned now and probably will show up in the middle of the 30s. Please, next slide. As I said before, the RAN is not internet. since the control plane is very important for the operators, and losing the control plane means losing money. The IP network is, say, rather than being packet oriented, it's a connection oriented fashion. So the operator, they take particular care on how they encapsulate and how they are positioning the security gateway for for traffic redundancy, and they use static routes. I can also tell you that they don't trust DNS. They assign manually IP address for having everything under control. Next slide, please. We are using, before Mikkel made a very nice presentation about all the feature current and planned for SCDP. What we use in Run is that the connection are semi-permanent. So for a telecom operator, there is no reason to take down an association unless a problem occurs. So it should be up forever, theoretically. We use two streams. One stream is used for generic control, and the other stream is used for providing independent non-head of locking connection for other kind of signaling. Multi-homing is the feature that operator like a lot because they can reconfigure the network, still the transport network, and still the run will be working smoothly. We do in-sequence delivery. I don't know any case of non-in-sequence delivery in the telecom. In the last time, there is a lot of effort on security, so we use encryption. And then since SCDP doesn't really trust the transport network, we use the packetization level path MTU discovery. That is also part of SCDP. And unofficial, so something that is implemented and it's using SCDP, but not in the way that SCDP has been designed, is that the timers. So we are using timers that are much faster than what is recommended in the original RFC, and we take care of timer accuracy. So we use a millisecond timer accuracy for our purposes. And then we use SCDP for link supervision, even though this is not written anywhere in the recommendation. The next slide, please.
Claudio, you have about 3 minutes remaining for these last three
One
slides.
of the reasons why we use SCDP is for latency. You don't think that it has anything to do because it doesn't start from user equipment to user equipment. But the case is that normally in LTE, any user equipment, a mobile phone, is in idle mode. So it doesn't have any carrier assignment from for transferring data. So you think that you are connected, but you are not, unless you do something, and then at that time your user equipment asks the network for resources. So it's like that the cable is unplugged from the network. You plug in the cable to the network only when you ask for it. And then the handshake for guaranteeing the user plane data requires 5 signals between UE and the core network. And the requirement is that it should be accomplished in less than 100 milliseconds. So if you want to make a ping from your LTE mobile phone, you will spend 5 handshake, and then you will send the ICMP packet and getting the RTT. And the measured time will be actually the sum of this initial handshake and the actual RTT. This is something that shows how important is the SCTP and the control plane for the experience of the low latency that a user has. Next slide, please. Can you, okay. And this is the other way, that is the link supervision. Yes, I will do that in 2 minutes. The other case is that we have the link supervision is important because when the connection towards the control plane is lost in the run, then you need to shut down the radio as soon as possible. And this is because if a radio that is not under control of the control plane can cause disturbance to the neighbor's radio, and at the same time, removing the power to the radio tells implicitly to all the user equipment that this radio is not working anymore, and they have to connect to another radio. So in the case of you are watching the Super Bowl and you are at the stadium, and one of the radio that is serving the stadium loses connection to the network. It is important that in a few seconds this is known, and then so that the equipment can hand over into another radio station. And this is the requirement, is that you should do that in less than 20 seconds. Next slide, please. I don't know if it's my last slide. Yeah, this is the weakness and that we have seen. So it's hard to make it work behind NAT, but Mikkel said it. Poor support in cloud. Implementations have some side effect with each other when in kernel or in the user space. Then encryption is not native. And then the last but not the least, one association doesn't scale well for capacity. Please do the next one. If you don't switch into the next, I don't think that maybe we can see that this is my last slide. Yeah, this is my last slide. Please close I close and ask if you have questions.
Okay, I'm not 100% sure if Claudio can hear us. There certainly was issues before. But regardless, if anyone has any questions, and if Claudio can't hear, hopefully maybe some of the other Ericsson people that are in the audience could back him up. Michael?
Yeah, so the question is the capacity one. So is it, so what is the limiting point here? We can't serve a gigabit, we can't serve 10 gig or 100 gig, or in which scale are we there?
No, not really. It is that it's difficult to scale over multi-core because of the design that requires this single point doing the SAC. That is difficult to implement. So you can, one association is a single point for the SAC, so it cannot grow up forever. Normally it is limited to the work of a single core.
So and connection terminates at a single endpoint, like a
Yes.
TCP connection or whatever. Okay.
Reese?
Yeah, so we have a question from the chat by Julius Krobocek. The capacity issue, is it a problem with window size or with congestion control?
Oh, no, no problem with Windows sides of congestion control. Everything works perfectly. But if you had more traffic on an association, then you will saturate the capacity of a single core, because I haven't seen an implementation that can spread a single association on more than one single core. This is because the way the protocol is designed.
Lars?
Yeah, I think it's a CPU issue because you can't offload SCTP like you can offload TCP to modern NICs, right? And so because of that, you're limited. by what a single core can do. And I guess these cores may not always be super powerful.
Jana?
I think I'm in. I'll speak to the specific point, and then I have a general question for the chairs. I have a comment that's more general. On this particular point, I think that it really depends on the implementation. If you're doing it in user space, you might be able to do fun tricks. But I can understand that with existing implementations, in kernel in particular, you'd have trouble scaling past a single core. So I get that. The general question I have for the chairs is: Are we having just questions related to the specific presentations, or are you also generally? I saw the theme here was SCTP today. Do you want to take comments on that?
So I'm going to cut the queue after Michael, and then we'll transition to open mic, and you're welcome to keep talking about SCTP if you would like to do that.
Okay, so I should do that now.
Let's have Michael follow up on this presentation one last time, then we can open the mic. Michael.
I'll just stay in the queue then.
Yeah, so just two remarks. One is NICs of some vendors allow checksum offloading, which is in the case of SCTP much more useful than in the case of TCP. So doing depending on the CPU you have, that's some CPU load. I'm aware of implementations which can do at least receiving packets in one thread, sending packets in another thread to some way. So you can do that, but that gets hard. You can't use more than 2, I guess.
Thank you, Michael, and thank you, Claudio, for your presentations. They were very informative. I certainly learned a lot. This now begins the open mic portion of the session. So if you have any comments at all about the transport area and any part of it, feel free to enter the queue, and we'll begin with Jana.
Thanks again, Martin. So at a high level, I think it's instructive to think about the fact that SCTP, when Lars's point earlier about the fact that SCTP was designed at a different time, had different potential end goals at the time. Not all of them manifested for various reasons. We understand them, I think, reasonably well today. And I will say that we've taken a lot of those lessons into account when we worked on Quick. And so it's played a significant role. That experience has played a significant role in where we've come today. Going forward, I would suggest, again, back to something that Lars mentioned earlier, that it would be really useful to understand the cases where SCTP needs to be developed in the places where SCTP is used. We can talk about features in general, but I think it's much more interesting to talk about the features. So Claudio mentioned that SCTP is going to be in the RAN for a long time, and I appreciate that. But use of the protocol doesn't necessarily mean that we need to keep developing it in ways that the current use cases don't need it to be developed. So I would suggest that going forward, it'd be really useful to understand for any extensions or any work that we need to do, who exactly is going to be using it. And that should also give you a pool of people to review and to do the work on future extensions. That's just a high order point.
I think, Jana, that's a very valid point. I think this is something called maintenance and developing new features. I mean, so in the maintenance part, we can have the protocol there, but we cannot forget about it, right? So that's one of the point parts here we're trying to make. But yeah, when you are talking about extensions and making some new development for a particular protocol, not only but SCTP, but whatever, we need to think about who is the user. So that's a very valid point. Thank you.
Philip.
So I was a little bit strived seeing the point of lacking cloud support for SCTP and especially Kubernetes there. And this reminded me of something I've been looking to a lot in the last years, and this is mainly how transport in Kubernetes works. And it looks like we really have some kind of disconnect from the HTTP dominated world, how people are doing network transport in Kubernetes and how the transport area in the IETF perceives transport. And I think this is really some point we should look into. Also, how slightly different the ideas of transport are. And I think this also explains a lot why we have problems, or why the SCTP community seems to have problems with Kubernetes support, because they Kubernetes has a very specific idea what transport is and how it works. And this is really centered on REST and HTTP, and not so much about what usually transport people at the IETF care about.
Michael?
Yeah, I just want to second what Jana said. And in addition to that, that's something we do for several years. So none of the recent SCTP developments, meaning new features, were done without some other entity requesting that feature. Some other entity might be another working group of the IETF or so. So this is something we do for, I don't know, 5 or 10 years now.
All right. Any other open mic comments at all about anything?
4 minutes.
Okay, 4 minutes ahead of schedule. Great. Thank you for coming. Thank you for everything you do for transport, and have a good rest of your IETF.
Thank you. Perfect. Perfect time on my computer. So what happened with this slide thing?
I have no idea. I mean, the slides are uploaded.
Slides are up. I mean, maybe we need to manually upload them to the before the session.
Oh, is there some button you're supposed to press? It could be you're supposed to press some button.
I mean, here it has the standing.
No, it's just introductory slides. That's just like free share slides.
I thought they're all automatically doing. Maybe this time we have to manually push them, download them and upload them.
Like this, it's in data tracker.
Yeah.
It's there. I don't know what the issue is. Well, it doesn't matter now.
This is the problem with this. We didn't have like discussions.
Well, I mean, a lot of people don't care. We knew that. Oh yeah, we didn't mention that, did we? Uh-huh.
So yeah, maybe we should do that, because I mean it only says like scan me to on, but in the beginning of that room it says like to register yourself. This is the blue sheet thing. There is yeah. I mean I think that.
Are we still having this problem that like people are not, don't know how this works? Okay.
Yeah. I think that's a very good point. I think we need to make it up.
Well, if we have, but there were like 80 people on the Meet Echo, so that goes into the blue sheets.
Yeah.
Yeah, but so those 80 people were like actually quite a lot of blue people, and then there were some Java clients as well. And I only counted 11 people who were had like in blue sites.
Okay.
I mean, I don't know. I don't have the real data, but I think we are actually. It's not this session only. I think.
No. I mean, I realize that this is the case. I mean, if you don't scan it, you are not on the digital blue sheet. And if you need to remember people, like only, I mean, the people, the idea was perhaps like you log in. Yeah, exactly.
I think not doing blue sheets was a mistake. Oh, okay.
And if it is like only online, then everybody has to log in, and then that's no problem.
But like all the chats just need to do the same reminders each time routine to sign in.
Yeah.
So you have to remind your chat.
Okay.
I'll not. Where I'm supposed to be? I'm supposed to be somewhere else. Webrtc. Okay, are we done here?
Yeah.
You got what you want? I know. You got what you want?
Yeah.
Das ist
It was a pretty good talk. I
Yeah.
mean,
Yeah.
Claudio's tech is terrible, but like,
I didn't get it. Like, why he can. I kind of realized, like, when he stopped talking, he could listen.
how does like how can someone have that kind of remote technology problem at this point in 2022? That's what I don't understand. How can someone have like a headset that can't send and receive at the same time?
I mean, this guy, we have this Microsoft Teams. I was talking with him just before. It was fine.
Okay, so it's a weird,
Browser thing.
it's a browser meet echo thing. Okay.
Maybe not Meta, but browser, maybe he allowed something, disallowed something. So,
Yeah.
maybe,